follow along with. So basically, like I fell in love with Ethereum after reading the white paper. I think I found it on Hacker News, and really like Ethereum led me to Bitcoin and understanding kind of what cryptocurrencies are. I'm more of on the developer side and not the like speculative side. So I definitely am more of a builder and less of a investor or whatever. So uh, for me, it was Ethereum, and it was about building smart contracts and what that means, and just the power of being able to deploy some code on chain and have that run in a decentralized way where, you know, tens of thousands of miners are basically cryptographically backing that code, and there's no centralized entity that is kind of, you know, dictating or crushing my dreams in any way, right? This is a very free and very decentralized system, and that's really awesome. So let's see, what I would say that if you go to ethereum.org /developers, there's a ton of tools here. And you're going to get hit with just like a bunch of links, and you'll just have to do some exploring. And I think that we'll get better and better at this and be able to show kind of a more coherent path of onboarding. But right now, kind of there's just a lot of stuff here, but there's, you know, you can dive in and really get to understand stuff pretty quickly. So going to my big break into Ethereum was around meta transactions and how we can do a better job with onboarding using this kind of EC recover function. So if I'm just going to use, let's see, I'm just going to sign a message here from the command line. We're jumping into the CLI here, getting weird on the CLI. But so basically, if we look at what just happened here, I just signed. So I'm using a key pair, and a key pair goes back to like cryptography from like 1983. But basically, you have a private and a public key pair, and you can share your public. You want to keep your private. But what you can do with that private key pair is sign messages, and that's kind of like what's kind of keeping all of this working. And basically what happens is I use this private key and I sign this message hello world with one of my accounts, and I have a Ganache blockchain running over here, but basically it gives me this signature. But what you can do with this is recover it. So if I pass in the message again and I pass in that that signature, I get back this, which is the account that I used to sign it. So that means that once I've signed something, anyone in the world can take my message and my signature and turn that back into my account, so they can prove that I signed that. And that's kind of how transactions work, right? A transaction has a to and a from and a value and some data, but what we do is we kind of roll all that up and we sign it and we put it on the network, and anyone can then prove that that person signed it. And then there's some proof of work and some hashing and some mining that goes into keeping all of that secure. But that's the trick, right? There's just this ledger that we send stuff back and forth on. So I got into the space building games. I built this game called Gallias, which is this oil-painted kind of token game where you're crafting ERC 721s and you're earning ERC 20s. And then I created a Pogs game where it's so good for ERC 721s. It's like this collectible with metadata with this gaming feature in where you're throwing slammers and getting rad. And what I realized though is that onboarding was really rough. And also like no one could get into my game, right? Like no one cared that I had this, that I poured my love into this game Gallias. And so what I needed to do is provide more value within the ecosystem, and at the same time focus on making onboarding smoother. And that's where meta transactions came in, and using this sort of sign and recover but on chain. So a user signs something with 1983 cryptography, and they take that message and then instead of putting that message on chain like a normal Ethereum transaction, they put that message into a relay pool, and so relayers pay the gas. They're somehow incentivized, whether they're running the app or you're giving them a cut or you're paying them a little bit. But basically, you as a user can just land on a site and you can generate a key pair and you can sign things, and you don't need to know about ETH. You don't need to know about gas. You don't need to download MetaMask. There's so many things that are hard barriers to entry for us that you can kind of go around, and you end up just putting stuff on chain, cryptographically backed, without having to do all that stuff. So that's where Ethereum meta transactions came in, and I didn't invent them. Someone else invented them. I just kind of put them together and evangelized them. Look, there's my little dude. So that is a link in this article also. But talking about hackathons and building something together, I think there's a lot of cool stuff in the space right now. NFTs are one of those. So I built this Nifties versus Nifties after Matt Condon put a poll out about whether we should put an I in the word Nifty. So I built these little generative, they're generated based on the block hash randomly of what they look like, but they're these collectibles, and you can vote on whether or not you want an I or a not I in Nifties. And I go through the hack here, and I go through like line by line kind of what I'm doing and what I'm building, and I kind of timestamp everything. So if you want to kind of like go along and follow me building, it's all here at Nifties versus Nifties in my GitHub. And that's just like a fun thing you could do for a hackathon. I think another cool thing to highlight would be like the pool together guys. This is something that you could build in a hackathon. Uh-oh, what do I need? Pool together Ethereum. So it's basically a no loss lottery. So come on, give me a link. It's like a no-loss lottery where anyone can, a whole bunch of teams or a whole bunch of people pool their ETH together. It's on Product Hunt. Go to the website. Oh, pooltogether.us. I should have done that. So you could build this in a hackathon. So and it kind of emphasizes the permissionless extensibility of Ethereum, where there is a contract that Compound has created that lets you put ETH or DAI in, and then you're loaning it out to other people and you're earning interest on top of that. So what Pool Together does is it lets you pool your funds with a bunch of other people, so no one loses any money. They just lock it all up in this contract. And then after some certain period, after all this interest has built up on everybody's funds, there's a commit reveal that does randomness, which I've also linked in that article that I put. Let's see. Yes. So in that article in the chat, down at the bottom, I talk about if you need a good tool in the toolbox is commit reveal. And so let's see if I click that. Yeah. So here's how to do like commit reveal on chain, right? So you can dive into that. That's a good tool in the toolbox. Hopefully with ETH 2.0, we can get randomness on chain, but it's particularly hard right now on the blockchain. But anyways, someone is randomly selected and they will earn funds. They will basically earn the interest that everybody else put in. So we all lock our money up, interest is accrued, and then one random person is selected to win the funds. So it's called a no-loss lottery. Everyone gets their money back, but the interest is paid out to everyone. It's clever things like this that I think really make a great great hackathon project. And I think it also kind of illustrates what you can do with programmable money. And I think that's one thing that really makes Ethereum great. Let's jump in and get some questions here also. If you have any questions, like jump into the chat. While I'm waiting though, I will go back to that article and we'll just talk about some smart contract features and kind of talk about what makes programmable money so interesting. So in this tutorial, I set you up, there's a signing. I set you up with a quick little dApp. And technically I could do that on the screen share. I'm not sure how much time I have to actually, I could build the dApp pretty quickly.
Hey, Austin, we've got about a little more than an hour slated. So if you want to get to building, like feel free to take it in that direction if you want to showcase things.
Yeah, that'd be awesome. Okay, so yeah, let's do that. So let me see where I'm at here. So I have a ganache running here, and you can, I think I show how to do that. Yeah, so let's kind of start from scratch. So ganache is running. What I've done to start is basically an MPX Clevis init. So I'm using my tool set, Clevis and Apparatus. They're just another set of tools in the toolbox. There's a lot of things on that website that are alternatives to this. I built this specifically to be for hackathons, for quick builds. So yeah, let's actually dive in and build something. That would be rad. So I've already set up Clevis. I can do like a Clevis version and prove that.
So rad, Austin.
What's that? What's that?
So rad.
Word wallet, what? Okay, so let's like dive in and build something. So we've already signed some stuff. Oh, npm start. So another thing I need to do here is fire up the, so once you do a Clevis or npx Clevis init, you have the ability to compile, deploy contracts, but you also have a React app that comes along with it. So I'll bring that up, and what I'm going to do is visit that app from an incognito window. So I'm going to do this away from, a lot of this kind of talk should be about onboarding and how we can do a better job of bringing people into the space. So you'll notice that I don't have any MetaMask here or anything that has to be downloaded or any concepts like having ETH. Like what I want is for someone to just like land on a dApp and start using it. And then once they've kind of earned value and tokens within that dApp's ecosystem or, you know, small space, they earn a narrative behind their account. Then they're going to be incentivized to kind of learn about, okay, it's almost like a Trojan horse into the center of the onion, right? You give them the core features of the app first, you let them use it, and once they're sold on it, then you start kind of selling them on the layers, right? And one of those layers is maybe downloading MetaMask or going to buy some ETH at Coinbase or something like that, right? So cool, yeah. So I have, oh, look, he already has ETH. Let's kill Ganache and start him over again. So we start with a completely fresh blockchain. There we go. And then this dude will not have any ETH. Yay! Okay, so basically when I landed on the page, Dapparatus has a React component ready to go that just generates me an account, and that account has 0 ETH, but that doesn't matter because of what we learned earlier about this sign and recover thing. So this account could technically be used to sign things, pass them to a relayer and put them on chain, and all of a sudden you've got like this instant onboarding, you've got people interfacing with smart contracts in a cryptographically backed way, but not having to have ETH or go through any of those downloads. We're gonna kind of dance around that a little bit, and we won't do a lot of the onboarding, but I think what I wanna do is just like look at building a smart contract and just kind of talk about a few little features that come along with building a smart contract. So yeah, actually let's see, it has me send that dude some ETH. Let's do that, we can do that. So this is, I think this is like my first, there we go. So now that dude has 1 ETH. This is like, for me, the first magic moment, like the goosebumps moment that happened is like, what just happened there? So like this one account over here, if I do Clevis accounts, we can see that this guy here, and then I could do like a Clevis balance and I can see how much money this guy has. So this guy here decided to send some money to this guy over here. Whoa, there we go, this guy over here. And what did he do? So he crafted up a transaction that said, I want to send 1 ETH to this guy from me. And then he used that sign thing that we talked about earlier. So he takes that whole thing, he signs it, and now he's got this signature that proved that he signed it. Oh, and there's a nonce in there, so no one can replay it. That's a key aspect. And then he kind of just puts that on the network, and the network picks that up, and if there's enough gas and all sorts of other things, it mines it in. And that becomes part of this decentralized ledger that everyone is basically respecting because of proof of work and mining. But there's so much cool, heady technology that goes into making this thing work. And if you go back and kind of read like the Bitcoin white paper, there's these magic moments where you just get goosebumps and you're like, man, that is rad. But then stepping that up, now we're not just sending money back and forth, but we can actually create smart contracts and we can kind of put these things on chain. So if I make just that same transaction, but instead I deploy a contract, let's go do that actually. So let's create a contract real quick. So Clevis create, we're just going to create a contract called some contract. And if I open that up in my editor, where did it show up? All the way over here. I got too many screens. Cool. So that's you want to look at the contract here. Boom. So we have this like skeleton of a contract. There's nothing here. There's a constructor. Not a whole lot going on there, but let's just, this is going to be very, very basic, but I just want to kind of dive into a few concepts just to get you going. So we're just going to create like just a public name, and we're going to call this guy Jabro. Man, it's hard to type when you're on a live stream. It's a lot easier. Jabroni snacks. A lot easier when you're doing it by yourself. Okay, so now we can compile that contract. And what does that do? So what that does is it takes this code that we've created and it rolls it up into some bytecode. So this represents, and if you go look at the white paper, yellow paper, you'll see that each little command that you have here has its own opcode, and those opcodes are built into bytecode, but you can think of it as kind of like machine code, right? So what we're gonna do, all right, now let's deploy that. So if we deploy our sum contract as account 0, so account 0 just sends another transaction, just like he's sending something from one guy to another, but instead there's no to address in there. And there's a data field. So the data field is, oh, we can't see it here, but the data field is basically this bytecode. So instead of me sending a transaction to a person, I'm sending them to no one with a bunch of data in it. And we as the miners on the network respect that as this bro just like tossed a smart contract out to us. And this thing now exists on all those miners within the network. So there's, tens of thousands of miners that, if this is my own, private blockchain running here with Ganache, but let's pretend this is on mainnet. So, tens of thousands of these nodes now hold this contract for me, and they all agree what its code is. And if we interact with it, they're all going to agree what the answer is. It's all deterministic. So if I say add 1, then all of them will receive that transaction. They'll all add 1 to the contract, and then someone out there will mine that block, and 1 gets added to the contract, right? So deterministic, shared state. All of a sudden, like this is for me, this is my next goosebumps moment. The fact that we could have like this shared state between all of us without any kind of centralization or any power controlling it, right? Like if you think about a database at Facebook, someone controls that. Someone really controls that, right? This is like a database in a different way. It's like everybody has a shared copy of the database. Obviously, storage is a lot more expensive here. You make trade-offs to get that decentralization. But we just put jabroni snacks on the blockchain. So writing a contract is one thing, but then you want to kind of be on the other side. If you're building a hackathon project, there's also the UI, right? So at the same time, the way Clevis and Dapparatus works is you can kind of, in symphony, iterate on both things. So you can be building your contract over here, but you can be building your UI over here. So let me just kind of dive into, Dapparatus has some components here. It has a contract loader, and it keeps track of transactions for us. So what we'll do is we'll bring in a contract loader, and that's going to bring up our contracts. And if I just hit save, I bet this dude just reloads over here. And now we have, you can't really see it, but in the background we have, uh-oh, I broke it. Oh, one last function here. We need to publish. And it's called Clevis test because you do like all these orchestration scripts too. But what that does is it takes our contract that's already deployed and it pushes it into the React app. So now the React app has the contract. We can say we're on block 3. You can't really see anything yet, but let's dive into that. So let's create some UI here. We're not going to do events. And I'm just going to grab this and move it somewhere else real quick. Ooh. Okay, back to our app. And if you have questions, drop them in the chat, shoot them out. We're just going to kind of jam on this for a little bit. So I want to go contract, some contract address. So now I think we should be able to see our contract. There it is. So our contract is actually deployed to that address, and it has 0 ETH in it. So let's do some cool stuff with it. Let's load our name in, right? So we've written this name Jabroni Snacks to our contract. Let's go read that from the contract. So what we'll do is we'll grab that. I think I have some code I've already written. I might be able to just copy and paste so I don't embarrass myself with so much bad typing. Let's see, what we're gonna do, there we go. So in the contract loader, once the contracts load up, let's change this to async, something I always forget. And let's just load the name. So we're gonna go to our contract, smart contract, we're gonna grab the name and we're gonna call that, and that's gonna give us our name back. Now that's gonna be in hex, so there's a little gotcha here, and I think, you know, as blockchain, as Ethereum developers, blockchain developers, there's a lot of these little gotchas that I think that we need to do a better job in the space of having this stuff prepared. So when someone lands on this, because this is kind of technical, right? We're grabbing the Web3 utilities and we're turning hex into UTF-8. There's a lot going on there that I think that maybe we could figure out a way to abstract it away. But what we just did is once the contract is loaded up, we're going to go out and talk to it and ask it what its name is, and then we're going to store that in our React state. So we're kind of just like wiring up the smart contract with our UI. And we're doing it in a very quick kind of iterative way that is very much kind of in the ethos of a hackathon. So now that our name is in our state, let's just display it in our UI. So we've got the address of our contract there. Now let's see if we get the name too. Come on, boom, Jabroni Snacks. Okay, so we've written a smart contract. We've turned it into bytecode. We've deployed it with a transaction to a blockchain, and it exists, it has storage. Now we've made an app and we've read from that smart contract. So what's next? And I think what's next is probably writing, right? Wouldn't it be cool if we had a function that lets someone actually update that? So let's see. Let me just, I'm gonna type it. Here we go. We're gonna create a function called setName. It's gonna take in a bytes32 name, and it will be public. Anybody can run it, which we'll mess around with in a little bit. And what does that do? Well, it just sets name to underscore name. Okay? So now we have basically set up a function that allows someone, and instead of me doing clevis test, clevis compile, clevis deploy, clevis publish, I can just do clevis test full. And it's just gonna run through all of that stuff, redeploy everything, and inject it into my front end. So it's a nice quick little, hopefully, let's see if it works over there. It looks like it's going to. Okay, so, and I've kind of written out all these steps in this article that I published in the chat over here, if you wanna kind of play along and follow along. Yeah, so now we've written our set name. Oh, now what we need to do is we need some UI, right? Like I said, kind of in Symfony, we're building our contract and we're building our dApp at the same time. And so what we need to do is get some UI in there. We probably need some kind of an input form. And you guys didn't think you'd be watching some dude write an HTML input form today, did you? Boom, there it is. And we're gonna need a button. Okay, so we have this set name input form that keeps track of it in the state. And then we have this button. Ooh, we can get rid of this stuff for now. We'll come back to that in a little bit. But basically, oh, and here's the little gotcha. We need to turn that name that we get back into hex. And then we're gonna call on some contract, we're gonna call set name. So just like a transaction that we run on chain where I send value from one person to the other, what I'm doing is I'm going out to all of those nodes that are holding my contract and I'm saying, I wanna run this function with these arguments. So I'm going out to this contract and it just has some address out there in the ether. And I'm going to say on some contract, I want to run set name and I want to give it my name, right? So let's see how this works. Boom, okay, so let's see. What we want to do is set our name to hello world. Oh, you know what? I know it's not going to work because it's not going to update. This may work, but it didn't update. Okay, so we need one more piece of UI, and that is when we update, we need to grab our name. So back to the UI where we're loading our contract, we're gonna say, oh, wait a minute, it's there. Oh, I know. It's in the Dapparatus update. So whenever there's a change on chain, we need to also track this. So let's go dive into this onUpdate function right here. This is basically any change happens on state. We will go to our contract and we'll do a read from the contract. So anytime anything changes, we'll go read from the contract to see what the name is. And on chain, a read is much, much cheaper than a write. You can read and read and read and read and read, but once you have to write, that's going to have to go to like all the miners and they're all going to have to mine it. So it's a big pain in the butt. What did I do here? Oh, async. I always forget that. Okay, so is that going to do it? We're going to have what we need here. And we'll see that it's going to update and it'll probably be hello world now because now the state reloads and it goes and grabs that information. But let's set it back to Freddy Four Fingers. All right, boom. Now let's see, boom, there we go. Okay, so we wrote to the contract. We put a transaction out there that tells all the miners to write that to the contract, and now we're reading it back into our state. So pretty cool stuff we can do there. If anybody has any questions, shoot it in here. I'm gonna make some big jumps in the UI. I walk through it purposefully. I walk through it like slowly here, and I talk about like each step and what we're doing. But I'm going to kind of shortcut that a little bit so we can get to some more Q&A and talk about this and kind of get maybe some more tools in the toolbox here. So what we'll do is let's go to our contract. And let's make a few changes here to this contract to make it a little bit more advanced. So this is programmable money, right? If right now we're just programming state, which to me is very interesting because I'm kind of a game developer and I love that. But I think that right now like DeFi is really big in the space and moving money around and programming money is really cool. And it's sort of like part of the protocol. So we should talk about that. So what we can do is we can turn this function into a payable function, which now means it can take value in. And what we'll do is we'll keep track of some cost variable, right? Cost is 0, and then we'll require, so this require function kind of brings in some cool stuff about how things happen atomically within a smart contract. You'll hear people talk about atomic swaps. So this require function says when someone gets in here and they try to set the name, we're going to force them to make sure that the value of that transaction that they're sending in to me is greater than some cost. And if it's not, unroll everything. So the transaction is completely invalid, right? So I could have a whole bunch of stuff that happens here and a whole bunch of requires, and if it gets to any one of them that it doesn't like or it doesn't like line up, it reverts everything. And that's what it means by an atomic swap. Is you can say, I want to send this guy this token and he's going to send me that token, and if anything goes wrong, revert everything. So that kind of brings up the atomic nature of how the execution works on the contracts. And what else? We need to do one other thing. And so what we're going to say is make sure that the value coming in is greater than some cost. And then we're going to set the cost here. So we're going to keep track of what the last person paid, and we're going to force everyone to pay at least that much to update this contract. So let's see if that compiles. And we're going to need some UI, right? In Symfony, we're editing our UI. So let's get out of here, CSS. I don't want any CSS. Okay, so let's go grab, what we're going to need is some kind of input box for paying. Was there anybody yell at me there? Nope, okay. So there we go. So what we're going to do is we're going to bring in an input box and we're going to let them pay in ETH. So we're going to keep track of what they're willing to pay. And then we're going to make a little change to our transaction where instead of just calling the function and changing state, what did I do there? We want to send some value in. So we're going to parse that pay amount. Oh, and this is pretty important too. You'll notice that there's this times 10 to the power of 18. And it's funny, so I think that there's a really great tweet about how in old programmer land, there was always an off by 1 error because everything was 0 index. So you'd want the first item, you needed to ask for item 0. It's really funny to me because in blockchain land, or in Ethereum land at least, we have this off by 10 to the power of 18. So if I were to just put pay in there and someone were to pay 0.1 ETH, that wouldn't work. It would be like 0.1 way, which isn't even a thing. So if I say 1 ETH, it needs to be 1 times 10 to the 18 because 1 here would be 1 way, right? So we're going to, we want this to be an ETH so it makes more sense. We're going to let people pay. Okay, so now I'm assuming everything is here. So if we say hello world and we pay, say, 0.1, so watch my balance over there. So I'm at 0.9. If I say set, we see that it changes to hello world, and we see that now the contract holds 0.1 ETH. So now it's not just an address that you sent money to, now the contract itself holds the value, right? If we were to take this contract and we were to go to Etherscan and say, how much does this hold? It actually holds 0.1 ETH. You would see that that thing has, I don't know what the price of ETH today is, but it's like 20 bucks. That thing, that contract now holds $20. And speaking of compound and pool together, I think it's holding like $100 million or something. So some of these contracts are holding a ton of money. And actually a contract now is almost like there's these smart contract wallets where instead of having a key pair, you kind of want to have a smart contract to be your wallet because you can do things like delegated execution and social recovery and a lot of cool things that you can't just do with a key pair. If you lose that private key, you are done. So there's a, the smart contract wallet thing gives you some better assurances. Okay, anyways, back to this. Now we've got a contract, we're able to pay. If I were to try to pay one again, it would fail, but if I pay, say, 0.15 and set it, then you'll see my money go away and I update the contract and you'll see this contract just slowly accrues value. So now we need a way to withdraw the funds, right? So let's dive back into our contract. Let's come up with some kind of withdraw function. Now, if I just have withdraw be public, then anybody is going to be able to just get in here and withdraw that. And this goes back to kind of the signed messages and then being able to know who signed what. There's this message.sender, and that's really important. So that tells me who actually is doing this transaction to this smart contract. So what I can do is I can require that the message.sender is the owner of this contract. And so to set that up, we'll just create a owner memory slot within, it's not memory, it's actually storage. We'll store who the owner is in the smart contract. And then when the smart contract is created in the constructor, we will set the owner to the message.sender at the time of construction, which means the person who actually deployed it. So what are we doing here? We're setting up a withdraw function so someone can pass an account in and withdraw the funds. And we're forcing it to make sure it's only the owner that can do this. And if all of that is set, then it transfers the balance of the contract to that account. So how cool is that? Basically, you have this account and you can do a transfer within a smart contract. It's programmable money. It's amazing. Okay, so let's save this. Let's see if this actually compiles. And we will, so normally in my UI, I would probably put a little withdraw button here, but there's this kind of thing where the owner is actually this like CLI, the command line that's going on here. So he probably will have to do the withdraw from the command line, but let's just do a hello and let's send in 0.1 and we'll see that my balance goes down and the contract gets some funds. So now over here from the command line, I can do, I'm gonna do a contract. Look at that, I've already got it already. Ooh, accept. So I'm calling the withdraw function on this, the sum contract as account 0, which is the guy who deployed it, so he is the owner. Ooh, let's actually check. If I were to do a Clevis contract owner smart contract, it would spit out my address. So just trust me on that one. We don't even need to check it. But one last thing is I need to send the funds somewhere. Let's send them back to this guy. So when I withdraw, I can withdraw to myself. But since this is sending to whoever I'm passing in, I'm just going to send it to this guy. And we should see this guy's that should, oh, there we go. He got his money back. There we go. So we withdrew from the contract. We gave it back to the guy. Kind of this is just a great little quick little introduction to how you can have these payable functions. You can move money in and out. You can kind of like really program the money and program how it's sent, and you're keeping track of addresses and you're sending money to those addresses. Really, really powerful stuff. So let's now kind of like open it up and just talk more about like where to go in the space for cool stuff. I would say that like the Open Zeppelin contracts, have I pulled them up? So open, Google is your friend, right? Open Zeppelin, Solidity. If we go look, that's my buddy from Nashville. He's got some great content too. Let's see, contracts. Let's go look at like tokens, right? So a very obvious thing, like a very first stop here is to grab an ERC20 token. And if we've kind of learned already today about there's already storage and we're updating these addresses. So an ERC20 token is pretty basic in terms of it's just like keeping track of addresses and then like a mapping to balances. This is like, that's it right there. Basically, you have this address that maps to some number, and that's that person's balance. So then they can send it around. You do that whole thing where you check to make sure the message.sender is them. And if it is, then you let them send their tokens. And so they can get in here and just say, okay, I have 5 tokens, send 2 of those to Gavin. And I sign that message, it goes on chain. The storage within the contract changes that little number to say, okay, now Austin has 3 and Gavin has 2. It all happens in a very like decentralized programmable money way, which is very exciting to me and very cool. Let's actually look at what it would take to extend this contract. So over here, I would do something like npm install, say, look at that, I've already done it, Open Zeppelin Solidity. So it's an npm package. You can just bring all these contracts in, right? So let's actually create some coin. How am I doing on time here? We good?
You're doing great.
Awesome, great. Any questions or anything?
Nothing flown in yet.
All right, awesome.
Amazing.
Word. Okay, so let's say that like now, like you kind of got the basics. It's time to like open up to this beautiful world of Ethereum and kind of like build on top of this kind of structure scaffolding we have. So a lot of this stuff is already written for you. There's tokens, there's role-based access. There's so much cool stuff that you can do. Go like kind of like look through this stuff. There's so much here. But let's like make our own token real quick. So I'm gonna do a Clevis create. We're gonna make a new contract. And this is going to kind of teach us about like hierarchy and stuff too. So let's see. Clevis create, we're gonna make some coin. Okay, we're gonna deploy our own coin. It's gonna be a shit coin. Here we go. All right, so we've got our some coin. If we go over here, we can see we've got some coin, right? So here's all you need to do. You need to bring in your that Open Zeppelin library. So we're gonna make a mintable token that allows us to make a call on it and have it mint some for us. Probably not the most decentralized because if there's one central account that can mint these, that's kind of bad, but good for examples. And then basically it inherits that. So this is an ERC20 mintable. And then just one last little thing. Look at how easy they make it for us. Boom. So we set the name of our coin. We set the symbol and the decimals. Remember that 10 to the power of 18. And boom, we've got a coin. So one little thing with Clevis right now is it doesn't handle dependencies very well. I'm pretty sure if you do a compile in Truffle right now, this will just work. With Clevis, I have to bring in all the dependencies and load them in. So I built my own thing. It uses the Solc compiler, and it could be better. But basically now we should be able to Clevis compile some coin. Oh, not some contract. We want some coin. Come on. Okay, so now this bytecode is going to be a lot more advanced. If we go look at the bytecode of our some contract, it's really pretty small. It's going to be pretty cheap to deploy. There's not much there. But if we go look at the bytecode of some coin, whoa, look at all that. Because there's lots of cool like transfer from and all this cool stuff that Open Zeppelin has done to make sure that you can do what you need to do, and there's a standard and all the wallets can respect that. So there's a lot more code there. If we look at what it looks like compiled, so this is kind of like the full code. You could take this code and you could turn it into the bytecode. There's a lot going on there. Like this is all we had to write, and this is what Open Zeppelin wrote for us. And Open Zeppelin is in, like, it's a whole community of people that are, I mean, if we go, can we even see commits? There's probably so many commits to this from so many different people. It's so rad. What a great ecosystem. So we've created our coin, we've compiled it. We could do that, we could do deploy some coin. And boom, there we go. We just created a shitcoin and we deployed it to the blockchain, and now it's got this space and this storage, and we can get in and probably mint. Can I do that? Let's mint this dude over here some coins. Not sure if this will work. Clevis contract. Oh yeah, it's there. Some coin 0. Nope, not that guy. And remember, we've got 10 decimals, or 18 decimals. So if I want to send this guy like 100 tokens, it's going to be 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 17, 18, send. So just a transaction on chain to the contract that represents the token. I am the owner, so it allowed me to mint that dude some tokens. So what if we want to display those? Let's go back to our UI real quick. How are we going to do this? I think we could just load the balance in, just to prove that I did this. Let's see, let's load the balance in here. So once the contracts are loaded up, we'll get a balance. So we're going to some coin and we're asking for the balance of this account that's here. And then we're going to save that into our state. Okay. And then we want to display that somehow. Let's use our cool colors here, but let's make it a different color. So this dot state dot balance, let's do BDEE. Who knows what color this will make? Okay, boom. Uh-oh, something's broken. Oh, let's do a Clevis, test publish, I think. I need to push the ABI into, because it's like, hey, there's no Suncoin. This probably should work. There we go. Oh, look at that. Oh, but dude, off by 10 to the, what happens if I do 18 here? Now it should be 100. Hooray! So we used someone else's code to create a shitcoin. We deployed the coin. We minted some to a dude. Now you can imagine there's a lot of other cool things you can do. Now we're not just programming money, but we're programming tokens. And so other tokens you could do, going back to my Nifties versus Nifties, there's ERC 721s, right? Which are basically non-fungible tokens. So they're tokens that hold state. So each one, or hold metadata. Each token is a little bit different than the other one. If we think of these coins, these sum coins are basically fungible. One is equal to the other. If I give you 10 of them, you have 10 of them. You give 5 to someone else. There's no difference between the 5 that he has or she has or whatever. So the non-fungibles carry like metadata, and that's where like CryptoKitties come in, and hats off to Dieter and the team at Axiom Zen of building, kind of really launching the NFT space into existence. And you can do all sorts of stuff with that metadata, and that kind of goes back to my Nifties versus Nifties, where each one has kind of like a different genetic sequence, and that's randomly set up. So at the bottom, I think we're basically kind of filled in a lot of stuff. EC recover. Okay, let's take a second to go look at the EC recover function. So that whole signature thing that we did, right, where we had signed messages, I would say if you're interested in getting, look at that handsome dude with the bow tie. If you're interested in doing great onboarding, I think, and you're redeploying your contracts, you're going to want to check out native meta transactions. And what happens here? Oh man, can I make that bigger? Let's zoom in. Oh yeah. Whoa. Oh, where is it? Zoom too far. Okay, right in here. So there is this EC recover somewhere in here. I did a talk and I couldn't find it either. It's here somewhere. I can't find it. Get signer. Oh, there's a function that's not even here. Let's just, here we go. To Google. Yeah, teach me about EC recover. So basically what EC recover is going to do is that same thing where we take some message and some signature, and it's going to give us back the address. And that's what's going on here, right? Except for, does it take an RSV? Does it take it split? Yeah, okay, it does. So this is something that you can do in a hackathon in that amount of time. It's really not that complicated. What you do is you're going to have this key pair that's automatically generated for someone in the front end. They land on your site, they've got a key pair. They can sign a message that says, okay, so in this example, in my meta transactions example, I think I create something called like a meta coin. So in this example, we have some coin, but you have to pay gas. to send that coin around, right? So I have to have ETH, and I have to understand what gas is, and understand a lot of stuff that maybe a first-time user is not going to have. So what you can do in this native meta transaction setup is you have this meta transfer function. Let me see if I can find it. Boop, doop, doop, boop. But what happens is you can make a transfer from someone to someone else without having to pay the gas if someone else is incentivized to pay the gas for you. So let's just say, and by the way, multi-collateral DAI that's coming out, the DAI contract, the ERC20 contract for the stablecoin DAI is going to be redeployed. And when they redeploy it, it will have it will respect signed messages. So you will be able to do this exact thing with DAI very soon. and what happens is, come on, give us some solidity. Who wrote this junk? I can't find it. Okay, let's just go back to our EC recover. So what happens here is you sign a message. Instead of me going to the contract and saying, I want to send 5 of my Sum coins to Gavin, I'm going to sign a message that says, I would like to send 5 of my Sum coins to Gavin. And instead of putting those on chain, I'm going to send that to a relay network. I'm going to roll up in that. I'm going to send 5 to Gavin, and whoever puts this on chain will get a half of one of my coins. And then I put that whole message onto a relay network, like the gas station network, or just running a centralized relayer. Depends on, all the game theory there and where the incentives align. But assuming that there's some party that is willing to receive my half coin to put this on chain, they'll take my meta transaction and they'll make a transaction to the contract and they'll drop it in. And my contract will do this EC recover on the message and say, okay, I can prove that Austin signed that message. And within that message, he said he wants to send 5 to Gavin. So we're going to send 5 to Gavin. And then he also said to give 5 to whoever relays it. So then 0.5 of my tokens will go to message.sender. So you kind of can do a lot of this cool stuff on-chain cryptographically backed without having to hit the user with a lot of these techniques. And I would say dive into this native meta transactions article if you're interested in that. I think I have that link at the bottom of the article I sent here. What else? So more tools in the toolbox. We already dove into the Open Zeppelin contracts. There's so much cool stuff here. If you just explore around, you'll just start getting ideas about cool stuff you can do. There's if crowd sale, if you want to sell your shitcoin. There's role-based accesses, which is pretty cool. So you can set up mentors and signers and whitelists and let people, certain people interact with it. There's so much content out there. Obviously, hit the developers page up on ethereum.org. There's tons of stuff there. I think that I wrap it up down here with commit reveal. So commit reveal is another another tool that you'll want in your toolbox. So random is hard, right? So if we're imagining all those miners and I want a random number, basically all those miners are going to have to agree on a random number, right? I can't just go to one of them and say, give me a random number, because it's going to be different for all the miners. So what you do is you set up this commit reveal, and it's a little bit clunky with the UX. We're working on it. I think that eventually random will be built into proof of stake, so it'll be something that you could just get from the network. But right now you do this kind of 2-step process where you generate a secret, and then you hash that secret and put the hash of it on chain. And then at some later block, you put your reveal on chain. And the code's all here. It takes a couple steps. The UX still can use some work, but that's actually how phishing works in Galeas too. I'll load that up while we're here. But you take that hash, you put it on chain, and now you've got the hash of your secret on chain, and then you have a block hash of the next block that is mined, and then later you put in your reveal. And your reveal is hashed with the block hash, and you get entropy. You get a random number, a seemingly pseudo-random number, as long as the player and the miner aren't colluding, because the miner could basically find a block and try to mine it, and it shows that they haven't won or something like that. So then the miner could choose not to put that on chain. So there's possible collusion, right? So random is still a tough problem, and we're working on it. And I think that the network protocol itself will eventually solve this. But commit reveal is another great tool in the toolbox. I think I've kind of covered a lot of the tools, the meta transaction stuff, the sign messages, just like what message.signer is, what message.value is, kind of what it means to compile and deploy a contract, and then kind of a lot of games need randomness. So this is my game Galleass, and these are some ships that are sailing on the blockchain. You'll see that even the clouds are moving if you watch closely. So everything here is in a smart contract. Though there is no backend to this game. This game just talks to Ethereum, and the Ethereum is the backend, right? So there's a smart contract that says like this cloud exists here and it's moving at this speed. And so you know that like 10 blocks later, you know where that cloud is, and you can see the clouds moving, and you can see each user here moving. And there's so much fun stuff you can do with this. One more shill, the DAO. So the DAO is, since this is like the year of the DAO, as Amin says, I've created this game called the DAO that lets, I'm not even gonna mess with that. Let's just Google DAO ETH. You think it's in Google yet? Nope, it's not. Oh, wait. Nope. DAO game, maybe. Come on. Yeah, open-ended decentralized game. So, yeah, cool. So the DAO is like this game where you can, let's just go to my Twitter. Of course, I've got something there. You basically, it's like this open-ended game where anybody can participate, and it's like this emoji-based game where, yeah, so there's a write-up about it, but let me find a screenshot. Yeah, here we go. So it's like this emoji-based game. See, there's like a tent emoji and a house emoji. So all the players are playing this, and then at the bottom of this, there's a Moloch DAO. Let's see. Oh yeah, here's the Moloch DAO. So there's a Moloch DAO at the bottom. So players are playing, and the game starts with a few set mechanics. Like, okay, we're going to have a tent, and that tent is going to generate smiley faces, and a smiley face will represent population. So then what we do is we vote in these new rules. I think Alex Van de Zandt was playing, and he voted in a chicken right here, and it's a discoverable. So you can discover this chicken emoji, and everything here is backed by a smart contract. So there's actually a contract out on XDAI right now that represents a chicken emoji that over the period of a few blocks being mined generates an egg emoji, and you can collect those egg emojis. So there's these beginning rules. You use a DAO to vote in new rules, and everyone's headed towards some victory condition. And if that victory condition is met, they're paid out. So say the victory condition was to collect 10 eggs. You would discover chickens, and then the first one to discover the eggs would win the game. So there's lots of fun exploratory stuff. The whole point of the game is just experimenting and figuring out, like, are there weird edge cases with governance? Can we make sure the game theory is solid? And let's do it in a way where there's some skin in the game. So in this particular, there was like 10 of some coin that I deployed, which you know how to do because we went through it today. But some coin I deployed to XDAI, so it doesn't really have value yet, but hopefully it does. So there's some skin in the game. You want to participate. You're incentivized to do well. You're competing with other people. You're participating in governance. So a lot of like fun things you can play with. And you'll notice like it's all built with the tools I was using today. And it's available soon to play. I think I'm about done. Like questions or things I should do? Anybody have anything they'd like to see me dive into? I don't know how we're doing on time.
We're doing, I mean, Austin, this is amazing. I mean, very sincerely, this is a really great dive, and it's a great dive as well as a look across a spectrum of what's possible and ways of interacting. As people, everybody listening, feel free to start throwing questions into the chat, and let's kind of move this to Q&A. One of the questions I have for you, Austin, is, are there any ideas, things you'd like to see explored from people who are building on Ethereum that, because you're busy building things, and it's like we have a community of builders who are tuning in and are going to see this over the next couple of weeks. Any ideas you'd like to see people explore, or things that you would like to throw out to the community that, like, hey, try this?
Yeah, for sure. I think that like onboarding is big. I think that adoption is big. I also think like DeFi is big right now. DAOs are big right now. So if you can find a way to kind of collide those things. So a good example of that is my homies, the FlexDApps dudes at ETH New York, built this stupid app, and they will agree it was stupid, but it's fun. Like, so what they did is you can post, I think you take a crypto kitty, and this also like really illustrates permissionless extensibility within the space too. But you take a crypto kitty and you stick it on a wall. It's basically like you're putting a sticker of your crypto kitty up with some amount of value, and the kitty is sized relative to that value, right? So you're putting a cat sticker up where everyone can see it, and everyone's participating on this cat sticker board. But what's actually happening is that ETH is being locked up in Compound, and you're earning interest on your ETH. So, normally you could just go to Compound and you could put it in, right? But I don't know what the UX is like on Compound. I think I've done it once or twice, but I think I used some third-party website. Just like UX needs to get better, but this was a really cool way to show adoption and usability in like a really fun way and extensibility. So basically people are, locking up their money and earning interest. But to them, all they're doing is sticking a cat on a wall that everyone can see, right? So it's like this kind of clever way to get participation. Same thing with the DAO, where I'm trying to come up with like clever ways to get participation in DAOs and get people like in a small skin in the game way, playing around with governance and finding these, like if we have $10 million in a contract and we find that there's some kind of game theoretic edge case that totally breaks everything, I'd rather we find it in like playing some stupid game for $25 than actually like with that $20 million. So I think that what we need to do is find cool things. NFTs are another example, like non-fungible tokens. That's another big thing in this space right now. So like non-fungible tokens, DeFi, DAOs, find edge cases along the way. Find things that people need to use, make things more accessible, make things more usable, and just get that participation going on. Whether it's a lot of skin in the game or not, we'll be able to see some cool things. We'll be able to maybe like learn about the technology and learn about the edge cases and figure out kind of new things in the space. Not a lot of questions. Guess I answered them all. Anybody else? It's a Q&A. Put it in the side chat. I'll answer it.
Oh my, having fun with these is boy, yeah, Austin, man. All right, people. So if there are questions, let's give it a couple more minutes for people to answer. Robbie also, Robbie Bent's on the line. He texted in one thing is looking at previous ETH global winners is a great place to find ideas.
Yep.
But where else should people go to get ideas around what to build?
Ooh, that's a good one. Like crypto Twitter is great. I like Evan Van Ness's Week in Ethereum. Just like go through the last like 2 months of Week in Ethereums from Evan Van Ness, and you'll get tons of ideas. There's so much stuff to learn from, just stuff that everybody else is already doing. ETH dev and /Ethereum or /r//Ethereum on Reddit. There's a lot of great stuff out there, and a lot of like just crypto Twitter, man. Like I feel like I spend too much of my day, scrolling through crypto Twitter, and there's just so many things that people are talking about and neat situations that we're building that I'm excited about. Let's see, top tools and front end to interact with smart contracts. So yeah, and I see Web3.js is there. Ethers.js by Rick Moo is another great tool that you'll use. Boilerplate React, yep. So for me, it's Clevis and Dapparatus because I built it for hackathons and I built it so I can iterate quickly. It's still coming along and it's not nearly as mature as some of these other products like Truffle and Drizzle and Embark. And I think that you'll find those here. Yeah, Waffle, Etherlime, from my dude George, Builder. I haven't actually used that one. I should probably check that one out. Obviously, the Open Zeppelin SDK is there. A lot of good stuff on this website. Ooh, ETH Fiddle. That's a cool one to talk about. Yeah, or like Remix, right? It's the same thing as Remix there too. Yeah. All right. This is like you can iterate on a contract even quicker with these tools, right? So here we've got a contract ready to go. You can just like compile and run it. So this gives you a good way to like play around with your contracts. If you're trying to come up with some idea or kind of seeing if this idea will work in production, this is a good place to start. I like to do the thing where I'm also like, oh yeah, eat fiddle, good link, good link. I like to do the thing where I'm also, and like all of these are sort of here, right? Let me post that in to make sure people know that that's, all of these things are like good for quick iteration. And that's why I like to use Clevis and Dapparatus, because I can kind of quickly iterate on both the contract and the UI. Because a lot of times I don't exactly know, like, in this Solidity, in this piece of Solidity, am I going to use like a mapping of an address to, a struct, or am I going to use an array? And I almost have to like play with it a little bit to figure out how it works, to understand like I'm a very trial and error guy. And so there's a lot of great tools to kind of have lots of errors and find your way to what you're trying to build. Anything else?
Oh, there's a couple more here. So there's in the Q&A. So Santiago asks, have you ever considered including upgradable contracts on Clevis?
Oh, that's a good one. Yeah. So I actually have just recently built into Clevis a when you compile, this works for actually the DAO. So it's called Sandbox right now, but this is the DAO. If I do Clevis compile the DAO, I also bring in the game contract, and the reason for this is the DAO contract proxies all the functions into the game contract. So basically for upgrades, I guess I should shortcut that or add some context here. To make an upgrade, you kind of need like this proxy contract that kind of like points to one contract, and then like when you upgrade, it kind of points to the other one. And like state is stored in one, and your logic is stored in another, so you don't like lose the state, or maybe you want to, but basically you have this proxy contract that can kind of point to contracts. And I did that like way back in the day with Gallias. Like Gallias was built, that ship game was built like 2 years ago now, or a year and a half ago. And I have this exact thing where there is this proxy contract that happens where, I'm not sharing my screen either, but I did Clevis compile DAO space game. There you have a proxy that kind of points to things. I am working on it in Clevis, but it sort of works, but I'm still kind of getting there. We should do a burner wallet demo too. Do you have a burner wallet, Gavin?
I do.
Oh, it works easier if someone doesn't have one. But let me like here. I'll share my screen and like create a fake one here. How about that?
Yes.
So let's do share again here. Okay, so here we go. We're in incognito mode. If I go to xdie.io, so this is kind of another one of my breaks in the space, was navigating the trade-offs of security in terms of usability and making things easier for adoption. So what's actually happening here is similar to what I was talking about earlier. There's a public-private key pair that's generated and dropped like right into local storage. We could go find the private key for this address right in local storage. Okay, so what I'm going to do is I'm going to pull out my burner wallet here, which is just a mobile device going to xdie.io. It's just this signing key pair, and it's stored in local storage, and it's on a fast sidechain. And so here it is. I've got $35 in it and some sick collectibles. So I'm going to hit receive on this dude, and I'm going to hit scan on this dude. And so now I've just got like a little video thing, and now I've selected it's reading the QR code. Okay, so it's like, hey, do you want to send some money to that dude? And you'll notice that's the blocky that we have here. I'm going to send this dude because this is totally going into the trash after this. I'm just going to send him like 2 cents or something like that. So we'll see that sending, boom, look at that. That dude just sent that dude 2 cents. So we've been talking about magic moments today. Another really magic moment is like using a burner wallet to buy food or sending value around. It's just fast, immediate feedback that like, oh, I just sent value cryptographically using a decentralized network, or decentralized, right? Because this is like a proof of authority kind of thing where there's a bunch of validators. One last thing I would add to this is like the request button. I can basically request to sell like 1 cent hot dogs. right? And I can put this up in my window. Basically what I've created here with I go to a website, a couple clicks, I've created a POS system. So now any random dude could be walking along and he could be like, oh, I want to buy that 1 cent hot dog. So he scans it and then it's going to give me the same thing. Like, do you want to send a penny to this dude for hot dogs? And we'll see, oh, I got a receipt. This guy sees that I paid 1 penny for hot dogs. He hands me my hot dog. I walk away. We all have a magic moment. Wonderful. Cool. What else? Ooh, emoji coin die exchange. So we're noticing that the burner is great for like onboarding. We basically have a key pair that we generate. You can send and receive value within the burner. You can send ETH here and exchange it from ETH to DAI to XDAI, all locally, within the native interface. Really, it's using Uniswap for that piece, and it's using the bridge for that piece. But what we're noticing is this is more like a platform. So if I go to emoji coin, do I have a write-up? There we go. And so I was asked to speak at this college class, and I walked in and like dropped these paper wallets on this classroom right here. And what they had was like this. So there's the paper wallets. They had an interface. I feel like I'm too zoomed in, a little too zoomed in. They had this interface that, if my internet will load, is like this trading platform where you can buy and sell these emojis and they fluctuate in value. And the game is like, the game theory totally falls apart. This game can totally be, easily manipulated because you could just run arbitrage on the emojis. But what I was testing is onboarding. What I wanted to see is who would be able to figure it out. If I drop a paper wallet on a classroom, who's going to figure it out? And the answer is like 80% of the kids in the classroom like immediately scanned that private key and were just clicking away on like making smart contract interactions, but not even really knowing that was a smart contract. So we're noticing it's more of like this onboarding platform. And so I'm just kind of like building games and kind of, hoping other people will use, if you Google burner modules, so if you're about to go into a hackathon, hint, if you Google burner modules, I've created this write-up. Oh, maybe I need to add like ETH. Oh, there I am right there. Look at this handsome, loud fellow. Oh, too loud. Ooh, I don't want to hear that. I can hear myself talking in the background. Okay, so burner modules are, so the burner wallet code is pretty gross. I'll admit to that. I had to build it like very quickly leading up to ETH Denver. I thought we'd clean it up after that and I'd get grant money, but that didn't really happen. So the code is gross. So what I've done is I've kind of ripped out this piece where there's just this like nice little React component that you can get in and you can just edit. Oh, look, we're using Clevis again. Man, old dog and new tricks. So basically you can check out the Your Module branch and you'll get this kind of, you'll be able to create a module on top of a burner wallet immediately. And a lot of people have done that for hackathons. There've been there's this really cool scavenger hunt app that's built on top of the burner module. Just a random dude in the community built a scavenger hunt app, and we're going to try to use it at ETH Berlin, right? So like build a module on top of this, and maybe we'll use it somewhere. Build a game, build an app. It's pretty easy. It's just like the same stuff that we did today with Clevis, where there's this TX function, and you kind of just pass in your contract and whatever the function is you want to call. So there's some nice abstractions there where you're not like directly having to mess with the contracts if you don't want to. It brings in all sorts of stuff like the network and the block and all the contracts, and you have a mainnet Web3 and you have a XDAI Web3. You can have the private key if you want to do stuff. But what I've tried to do, oh, there's the emoji coin interface right there. What I've tried to do is just make it really easy for someone to extend the burner wallet and use it kind of as this onboarding scaffolding without having to mess with all my dirty code, and then kind of create this module that then we can, when next time, next event where there's one of these cards that I hand out, you'll see a bow-tied guy handing out cards, you'll scan it, you'll have a burner wallet, but you may have like some app on top of it, right? And that's what's cool. At Ethereum, we had cards, we handed them out, you had these RAD tokens, and you could buy food at the food trucks, but while you were waiting in line, I worked with the Helena guys to create a prediction market inside the burner wallet. So while you're waiting in line, you could just tap a few buttons. Again, instant onboarding. You just have it. There's no download. There's no seed phrase. You have like, will this thing happen in Game of Thrones? yes or no, and how much would you like to bet on that? And you can just buy a position in a prediction market like that fast. And I think that this is sort of like a scaffolding for all sorts of fun onboarding stuff. Ooh, it's xdie.io there in the chat. Okay, what else? I think we've got to be about out of time.
Yeah, we are.
Boring you.
We're closing in. It's really nice. The unspoken thing of what you're doing is you're introducing the imagination and people to the fact that security is a moving bar based on what the use case is. And so it's not always this this standard that everybody needs to necessarily meet, but what you're just doing a beautiful job of is showing that there is this there's this medium. Yeah. And everybody has, so there is no one way. And in a hackathon, this is a particularly great place, especially because the last 2 weeks are focused on adoption. So playing with and understanding the difference between the high bar and the low bar and what are good for which cases is a really great thing to just call out, which I am appreciating immensely.
And to get my dad on board, I sort of have to give him the low bar first, right? Yeah. And give him the magic moment and the experience. And then so say at DevCon, I wrote this collaborative storytelling app, and you could write the lines of the story. And then let's say you write a cool line of the story. You don't have to have ETH. You don't have to understand MetaMask. You just dropped into what feels like a Web 2.0 experience, and you started telling this story. Let's say you write a particularly creative line, and a bunch of people throw some tokens your way, right? So now my dad has tokens. What are these things? How do I protect them? Now he's thinking about security, right? Yeah. That's the layers of the onion. All of a sudden, okay, I do want to learn about security.
Yes.
And I say, okay, well, here's what a seed phrase is.
Then the interest.
How you download MetaMask. And then he's like, okay, I'm going to do that because I want to protect my storytelling tokens.
Yes, there's a big difference. It's once the interest is intrinsic, then the motivation is just is part of this system, right? One last thing here. How do people who are kind of, if you're okay with that, get in touch with you if they want to talk about things or follow up, or if you're comfortable sharing that? It's from
Absolutely. So I'm at Austin Griffith almost everywhere. If you want to look at my disgusting code on GitHub, I'm Austin T. Griffith. But basically at Austin Griffith, hit me up. I'm a very approachable dude. Find me at the next event. I have a baby on the way, and it's probably going to be born in the middle of ETH Denver and DevCon, so I may not be at some of these events, but find the dude with the bow tie, hunt him down. Hit me up, because honestly, I had a hard time getting into the space. If you read that, my big break in Ethereum, it was tough. And there were definitely some trying times, even within my little family, about me getting into the space and how hard it is. And sometimes you think you have a great idea, but you need to learn to just throw it away and keep iterating. So it's tough. And getting into the space, especially as someone who's, already earning a good salary somewhere else, it's really hard to get into the space because it's, it doesn't pay that much. I took a pay cut to get into Ethereum for sure, but it's because I going back to the intrinsic nature of things. I love it. So many goosebumps moments happen within this ecosystem. Oh, and Robbie dropped in his stuff, definitely.
All right, people. Well, man, Austin.
Thanks for having me.
Really beautiful job today. Thanks everybody for tuning in, and we'll be sending, we'll have a link out to this video recording soon. And enjoy the hackathon and enjoy the building. All right.
Yeah, thank you. Enjoy the IDEO hackathon. Thanks for having me. Yeah. All right. See you guys later. Thank you. Happy Wednesday. Happy Wednesday. See you.